Okay, our next topic is we are going to discuss the vectors, and this is the section 12.2, and here we will discuss the vectors. So if you remember from your previous knowledge, what are the vectors? Vector is a quantity which is described by the two things. The first one, it is the magnitude, and the second thing, it is the direction. So in order to describe the vector, we should describe what is the length of this vector, or what is the magnitude of this vector, and what is the direction. So you can imagine, for example, this is our starting point, origin, and here we have a point A. So you can say that this O, it is the initial. This is the initial point of the vector, and this is called the final point of the vector. Sometimes we call this the tail, and sometimes we call this the final point as the head of the vector. And the direction is from the point O to the point A, and from this to this thing, this is called the magnitude of this vector. Magnitude of the vector, or the length of the vector. The next thing we are going to do, how are we going to define these vectors in the 2D space and also in the 3D space. So let us first consider this in a 2D space. For example, here what do we have? We have 2D space mean we are in the XY plane. We are in the XY plane. Okay. And in the 3D mean we have three axes as we discussed in the section 1, X, Y and Z. Now suppose that we have any point if we have any point in the XY plane, okay, a vector A, it is given by these 2 points A1 and A2. Okay, remember this thing, you have to note down that the vectors in this chapter, they are written within the angle brackets. We call them the angle brackets. The vectors are always written in these angle brackets. So the first component will be the X component, and the second component will be the Y component. Similarly, here in the 3D space, okay, if we have a vector A, it is going to have the three components A1, A2 and A3. So a vector in 3D space, it is represented by these three components. Let me draw a picture for this. Okay, so you can imagine here. So this is the first picture. It corresponds to a 2D, a vector in a 2D space, yani XY plane, and the second one, it is in the 3D space, XY and Z. The next definition, it is of, if we are given 2 points in the XY plane, how can we find the vector between the 2 points? So this is the definition we will use here. Okay. So what do you need to remember here is the following, that we have 2 points. Okay, The coordinates of point A are x1, y1 and z1, and the point B has the coordinates x2, y2 and z2. What he says that we want to find the vector between these 2 points A and B. How can we do this thing? Okay, how can we do this thing? So you can imagine, you can say this point A, this is our initial point, and the point B, this is our final point. So what is the formula here? The formula here is the following, that the vector AB, it can be written in this form: the final minus the initial, final minus the initial point. This is how you can remember this thing, final minus initial point. So which is equal to the vector OB minus the vector OA. OB and OA are the position vectors of the points A and B with respect to the origin. These we discussed in the previously in the section 12.1. So the position vector of the point OB, it is x2, y2 and z2, and the position vector of the point A is x1, y1 and z1. Now when we take the difference of these two, we will get the following: x2 minus x1. That is, we take the difference of x components and then we take the difference of the y components and followed by the difference of the z components, that is z2 minus z1. So that's how you can find the vector between the 2 points, and you can denote this thing, let's say, by the letter A. So this is our vector. The next thing is the following: how can we find the magnitude of this thing, the magnitude of the vector? Okay, so in order to find the magnitude of the vector, we have this formula. So in 2D we can find the magnitude of a vector by this formula, which is under the square root a1 square plus a2 square, and in 3 dimension we have this formula, the absolute value of a, or the magnitude of a, it's equal to square root of a1 square plus a2 square plus a3 square. So by these formulas you can find the distance or the magnitude of a vector. Let's do an example. So in this example we are given 2 points A and B, and what is the question? In this question what he says that we need to find the vector represented by these 2 points, with the initial point is A and the terminal point is B. Okay, so how can we find this thing? This will be very simple. Mean OB minus OA, and when we substitute these things, what do we get here? Minus 2 and then minus 2, that is x2 minus x1. So remember this thing, what are the values of you can say this is x1, y1, z1, this is x2, y2 and z2. So what will be y2 minus y1? It will be equal to 1 minus 3. Okay, and z2 minus z1, it will be equal to 1 minus 4. And when you simplify this thing, you will get minus 4, 4, and -3. So these are the components of the vector AB. So the main thing you need to remember is the following, that is you need to find uh, first you need to find this thing x2 minus x1, y2 minus y1, and z2 minus z1. And let's say we also want to find the magnitude of this vector. What is the length of this vector? Then you can apply above formula. So this formula will give you the following: minus 4 square plus 4 square plus minus 3 and then square. And now you can simplify this thing. Minus 4 square, it is 16 plus 16 plus 9, which is equal to 16 plus 16, it is 32. 32 plus 9, it will be equal to 41. So 41 is the magnitude of this vector AB. It is the magnitude of this vector AB. So this, by this formula you can easily find the magnitude of a vector. Now there are some properties of the vectors you need to remember. The first property says that if we have the addition of two vectors, it is commutative. That is, for example, like in the case of the numbers, we know that, for example, 2 plus 3, it can be equal to 3 plus 2. It is equal to 3 plus 2. Similarly, in the case of vectors, you can write a plus b equals to b plus a. Similarly, we know that from our previous knowledge that 2 plus 0 equals to 2, and which is also equal to 0 plus 2. So any vector which is added to a 0 vector, the answer will be the original vector. Similarly, 2 plus minus 2, this is equal to 0. So when you add a number with the negative of it, the answer is 0. So here we have the vector A. When we take its sum with the minus of A, okay, the answer is equal to 0. So what does this mean? Suppose that this is the vector A. What will be the minus A? It will have the same magnitude but the opposite direction. So when we take the sum of these two vectors, we are like we return at the origin. So these are the some properties of the vectors which you need to understand. Okay. The next thing, it is very important, which you need to understand. We call them the standard vectors. Okay. What do we call them? We call them the unit standard vectors. Unit standard vectors. So what do we mean by them? So here, let's first of all, here we consider the 2D, and on this side we will consider the 3D. In the 2D case, we have the XY plane, and in the 3D space we have this 3D space. You can imagine this x, y, and z axis. Now, what are the unit vectors? And before this, what is a unit vector? A unit vector is a vector whose length is equal to 1. In the 2D case, we have the two standard unit vectors. The first one here, it is denoted by I, and the second one, it is denoted by J. It is parallel or along the y-axis. So the vector I, so in 2D with the vector I, it has the components 1, 0, okay, and the vector J, it has the components 0 and 1, 0 and 1. And in the 3D case, along x-axis we have I, along y-axis we have j, and along z-axis, meaning in the direction of z, we have the unit vector k. And these vectors are given by the following components. Mean the unit vector I, it has the components 1, 0, 0, and the vector j, it has the components 0, 1, 0. As we have discussed previously in the previous section, that on the y-axis x and z components are always 0, and the k unit vector k, it is given by 0, 0 and 1, because we know that on the z-axis x is equal to 0 and the y equals to 0, y equal to 0. So the next thing you need to remember that any vector in the 2D space can be written as a linear combination of these three vectors. For example, here we have a point, or we have a vector A, which is given by this A1, A2, or you can say x or y. Okay, you can say x or y. So this vector A can also be written in this form, A1 multiplied with I plus A2 multiplied with the vector j. So this above vector can be written in this form. Similarly, here in the 3D space, suppose that this is the vector A and it has the components A1, A2 and A3. So this vector, it can be written as a linear combination of the vectors I, j and k. That is A1 multiplied with I plus A2 multiplied with j plus A3 multiplied with k. That's how you can express these vectors in terms of the unit vectors, standard unit vectors I, j and k. I, j and k. This is a very important thing to understand, because we will use them again in the next sections. So I, j and k are the unit vectors, standard unit vectors along x-axis, y-axis and the z-axis. Let's do an example. How can we do some mathematical operations if two vectors are given in the component form? So in this example number 5, a vector A, it is given by I plus 2j minus 3k and the vector B, it is given by this, and we want to find this thing 2a plus 3b. Okay, we want to find 2a plus 3b. What is the main question here? He says that express this new vector in terms of I, j and k. So what you need to do, you have to substitute the value of a here. A equals I plus 2j minus 3k plus 3 multiplied with, what is the vector B? It is 4i plus 7k. There is no j term, so you can write it as 0j. Now first we multiply this 2 inside the bracket, we get 2i plus 4j minus 6k. Similarly here 3 multiplied inside the bracket, we get 3 multiplied with 4, which is equal to 12 I plus 3 multiplied with 7, it is 21k. Now we can add the like terms, that is this 2i, it will be added to 12i, so 2 plus 12, it is equal to 14i. Now 4j, there is no other 4j, it is the only term, plus 4j minus 6 plus 21k, that will give you 15k. This is that's what he was asking us, that is expressing 2a plus 3b in terms of ijk. This is a very important type of important type of thing which will come in the exam. The next thing is you need to understand is the following, that is what do we mean by a unit vector. Okay, so here in this definition, what do we mean by a unit vector? So what is a unit vector? A unit vector is a vector, its length is equal to 1. Okay, a unit vector is a vector, its length is equal to 1. And for instance, I, j and k are all unit vectors, their lengths are equal to 1. Okay, now what will be the problem here? The problem will be the following, that is we are given, let's say, a vector a, and suppose that its magnitude or its length, it is not equal to 1. Okay, so our first question or our first problem will be the following, that is we want to convert a into a unit vector. We want to convert the vector a into a unit vector. How can we do this thing? How can we do this thing? For this we have the following formula, which he says that we can convert a vector a into a unit vector by dividing the vector by its length. Okay, what you need to do, we have a vector a, we divide this thing with its magnitude, we get a new vector, and that vector will be a unit vector. Its length will be equal to 1. Its length will be equal to 1. And this type of the questions, this type of the question will be given in the exams or in the problems. So for example, let's do this question. Example number 6, what we have to do, we have to find a unit vector in the direction of the vector 2i minus j minus 2k. Okay, so we can suppose this vector as the vector a, which is 2i minus j minus 2k. The first thing you need to do is to find the magnitude of this vector. You can apply the formula 2 square plus minus 1 square, because the coefficient of j is minus 1, plus minus 2 square. So this is equal to under the root 4 plus 1 plus 4, which is equal to square root of 9, and square root of 9, it is equal to 3, and we know that 3 is not equal to 1, so it means that a is not a unit vector. So how can we obtain a unit vector in the direction of this? You can apply the above formula. It will be equal to 1 over magnitude of a multiplied with the vector a. So it becomes 1 by 3 2i minus j minus 2k minus 2k. You can leave your answer at this point. Okay, you can leave at your answer at this point. This is a valid, or in the next step you can multiply this 1 by 3 inside the bracket, then you will get 2 by 3 I minus 1 by 3 j minus 2 by 3 k. So this is our unit vector. It is a unit vector in the direction of the vector a. So suppose that our vector a was this, and we know that the magnitude of this vector, it is not equal to 1. So what we have done here, we have done the direction of this vector, or we have find out a unit vector in the direction of a. So this is a unit vector, and the magnitude of this unit vector, it is equal to 1.